since you're not going to get to do a practice test, then
Yes.
I won't put any problems on the test. Or we got to try to think. There won't be any. Much just be like the homework. Picked up half a notch. Or maybe not even any notches. Okay, so last night's homework was on combinations. Oh, you guys could do number 1. Very good. And then number 2, card problem. Remember I told you card problems are hard. That's why. No, but these are not hard kind. Easy kind. Deck of 52 cards. 5 cards are dealt. How many ways can you receive? What are we doing? 2H. Good joke. Wait a minute. How can you do 2A but not get 2C? So we just do all of them? Okay, first of all, you gotta know what a face card is. Does everybody know what a face card is? That's a card with a face on it. No, I'm serious, but you gotta know what that is. Some students don't know. If you don't play cards, how are you gonna know? But you better know for the test. A card with a face is what? Jack. Jacks are in the deck. There's 12 of them. So if you're going to get 5 cards and they're all face cards, how many ways can you select 5 from the 12? 12 choose 5. Okay, I'm just going to write down the formula. You guys are responsible for the computation. No face cards. How many cards in the deck are not face cards then? 40, right? So 40 choose 5. At least 1 face card. Now remember, just like today's quiz and the homework, whenever you see the phrase at least 1, what are you going to do? You're going to do the complement and subtract it from the total because it's easier. Otherwise, you got to break it up into the cases. You got to go 1 face card, 2 face cards, 3 face cards, 4 face cards, and then 5 face cards, and you got to add them all up. See the phrase at least 1, do the complement, which is no face cards, which you did in problem B. Subtract that from the total, which is 598,960. Yeah? No. Anyway, do you think I'm going to give you numbers that big on a quiz or a test? No. How would you? So like on a test, instead of making a 5 card hand, I'll probably make a 3 or 4. It's not going to happen. Okay, it says at least 3 face cards. Okay, now, what does that mean, at least 3 face cards? 3, 4, or 5. Now, this is where you got to think. Is it better to compute it directly? Complement and subtract it from the total. Now, what is the complement of at least face cards? 1 or 0 face cards. And then you got to subtract that from the total. So that's like 4 computations you got to do. So isn't it better just to do it directly? So 3 face cards, at least 3 face cards means 3, 4, or 5. Okay, here, these are the 3 cases. So how many ways can you select 3 face cards? What are there? 12 choose. Then the other 2 cards are not face cards, so 40 choose 2. Now what about 4 face cards? 12 choose 4. 1 not face card. And then all 5 face cards. And no non-face cards. Of course, 40 choose 0 is 1 then. That's like the committee one, right? That's pretty much like the committee. Anyway, don't worry, the numbers are not going to be this big on the test. In fact, if you want to use a calculator for your homework for this one, how about just write that down and look at the answer on the bottom, like you guys normally do. All of 1 suit. Okay, do a specific case. Clubs. How many clubs are in the deck? Alright, so this is how many ways you can get 5 clubs. So, chapter 4, because there's 4 different suits, right? It's club, that's kind of a big number. F, at least one of each suit. Ooh. Okay, so let's think about it. What are the suits? This problem's going to be on the test. Spades, hearts, clubs, diamonds. You have five. What am I talking? You have a 5-card hand. What are the categories? You have 2 spades, hearts, 1 spade, 1 club, 1 diamond. Or you could have 2 clubs, 1 double, 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 or you could have 2 diamonds, 1 double, double, double. Right? Are there any other cases where you have? Okay, so let's do the first one. How many ways can you get 2 spades? Club, 1 diamond. And then can you see when you do all the other cases, it's going to be the same numbers? So instead of adding them 4 times, multiply by 4, it's a lot easier. Again, that number would be too big for a test, so instead of at least 1 of each suit, I don't know what I would do. 4 of a kind. We did 4 of a kind. Didn't we do 4 of a kind on Friday? That's okay. Again, do a specific case. 4 aces. Ace, 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 ace. And then the 5th card can be anything, right? So, out of the 4 aces in the deck, how many ways can you select 4 of them? How many cards in the deck are not aces? 48. How many ways can I select 1 of them? 48. Choose 1. How many ways you can get 4 aces? And if you just think about it, right, you can have 4 aces and the 2 of diamonds, 4 aces and the 3 of diamonds, 4 aces and the 4 of diamonds. So this about 4 of any kind then. Multiply by 13, right? Because there's 13. Then, didn't we do this? Go to your room. Why do we even, did you guys even watch the? That's okay. No, we didn't do 2 pairs. We did 1 pair, yeah? Yes. Okay, so 2 distinct pairs. Okay, pick a specific case. 2 jacks and 2 twos. On the card, the 5th card cannot be a jack or a 2 now. You guys understand why? Yeah, because it's going to be a full house. But then some people, I got 2 pairs. Okay, so how many jacks are in the deck? 4. How many ways can I select 2 of them? 4, choose 2. Same thing with this. Now the 5th card cannot be a jack or a 2. How many cards in the deck are not jacks or 2s? 4. So how many ways can I select 1 of them? I think everybody can do this, right? But now the multiplication factor. This is the specific case which is jacks and 2s. Sorry, because you can have queens and 7s. So forth. What? 13, choose 2 is the multiplication factor. Because look, you got 13. Whenever you do card problems, you should always write this up. There's 13 values. How many ways can I select 2 different ones to be? How many guys is this? This 8 people, right? You got 8 people. We're going to make a committee of 4 people. If Bert and Ernie must either serve together or not at all, how many committees are possible? So what are the 2 cases? Bert and Ernie are on the committee. Bert and Ernie not on. So on the committee. Now, if you take away Bert and Ernie from the list, how many people are left? There's 6 people left. How many ways can I pick 4 of them? Oh, Bert and Ernie are already on the committee. So we just need 2 more people to go with them, right? And then if Bert and Ernie are off the committee, that means you have to select all 4 people for the committee. So how many ways can you do that? And what do you do with these 2 numbers? Add them Wait a minute, everybody can do number 4. This is the important thing you got to learn from that, you know. Shall we? That you guys don't feel shame on Mondays. 4. If you have a penny, a nickel, a dime, a quarter, and a $half, how many is that? Penny, nickel, dime, quarter. That's 5 different coins. How many different sums of money can you make? Now, there's a very important concept that goes with this now. Okay, so one way you can do the problem is go, hey, okay. Okay, there's 5 different coins. Okay, think of this. There's 5 coins here. How many ways can I select one of them? Because you can use 1 coin, 2 coins, 3 coins, 4 coins, or 5 coins, right? So, first one, okay, I'm going to make a 1 coin. 1, right? Out of the 5 coins, how many ways can I pick one of them? Okay, now from the 5 coins, how many ways can I pick 2 of them to make a sum of money? 2. And then what about a 3 coin sum? 5 choose 3, 1, and then 5 4, and then 5 choose 5. How come I don't put 5 choose 0? Because a sum of money, you got to have at least 1 coin there, right? Otherwise, you don't have a sum of money. And then what do I do with these numbers? You add them up because there's a big space in between. That or they're mutually exclusive cases. Now watch this. There's another way to do the problem. Watch this. First coin. Here's the penny, the nickel, the dime, quarter, and the $half. Or is it the dollar? Okay, how many choices does the penny have to be in your sum of money here? Sum of money in my hand. Here's the penny. How many choices? 2. It's either in my hand or not in my hand, right? It's in the sum or not in the sum. What about the nickel? 2. It's either in the sum or not in the sum. What about the dime? 2. What about the quarter? 2. What about the $half? 2. So on the test, if I add like the 6th coin, is that going to throw you off? Yeah, but Mr. Park, this one came out to 31. This is 32. That's because you have to subtract the one case where you didn't use any of them. If you don't use any of them, that means you don't have a sum of money. And do you understand why this works? Okay, let's go back to Pascal's triangle. In the 5th, what are the numbers in the 5th row of Pascal's triangle? 5, 10, 10, 5, 1, right? But what are those numbers? 0, 5, choose 1, 4, 5, choose 5. These are the numbers in the 5th row of Pascal's triangle. And I told you this, but I don't know if you guys remember. If you add up all the numbers in any row of Pascal's triangle, what are you going to get? 2 to the 5th. So if you go to the 7th row of Pascal's triangle, you add up all of those numbers, you're going to get 2 to the 7th. So tell me, why is this equal to this then? Just look. If you look. Dad, this is 1, right? Move the 1 on that side. That's 2 minus 1. Okay, and then finally, okay, number 5. Oh, we got it. Oh man, we're in trouble. How many ways can you distribute 12 candy bars to the 3 Stooges? You guys know who the 3 Stooges are? Watch that. So, now this is a combination. It doesn't matter who goes first. Who do you want to go first? Mo. Okay, Mo goes first. There's 12 candy bars on the table. Mo, pick 5 of them. How many ways can you do that? Well, choose 5. Okay, now how many candy bars are left after you took 5? 7. Okay, now it doesn't matter who goes next. Okay, Larry, you go next. Pick 4. 7, choose 4. Only get 3 candy bars left on the table. Curly, take 3. And it doesn't, and you can check this. It doesn't matter who goes first. Like, okay, what if Curly went first? Curly, pick 3. Well, choose 3. 9 left. Who do you want to go next? Okay, Larry, pick 4. 9, choose 4. Okay, Mo, pick 5. 5, choose 5. It doesn't matter. These come out exactly the same. Combination, the order doesn't matter. Okay. Okay, today, now that we got permutations and combinations out, hopefully you guys know the difference by now. Now we're going to learn harder problems. Like, now this is where you get your mind blown. So did you or did you guys not study permutations and combinations last year? Some people are saying yes, some people saying no. Because if you did, then everybody did Mississippi, right? Okay. Okay, what if you have 6 different letters? A, B, C, D, E. How many 6-letter words can you make? Now, when I say a word is just an arrangement of letters. Now, a word is just an arrangement. So that's a word. How many 6-letter words can you make with 6 different letters? What's the answer? 6 factorial, right? Because then you would go like this. Get 6. Right now you can just go 6 factorial. Okay, but what happens when you get repeated letters? Like what if you have A, B, B? How many 6-letter words can you make now? Is the answer still 6 factorial? No, Moose Breath. Why not? Because look, you see this A and the B. If I switch the A and the B, is that a new word? Is abs-to-def the same thing as back-def?
No.
No. So if you switch 2 letters here, it's a new word. But what if I switch these 2 B's there? Is that still the same word? Yeah, so what do we do when there's repeated letters? Yeah, so since there's 3 A's, you divide by 3 factorial. And since there's 2 B's, and if you want to, got 1 C, so divide by 1 factorial. So this is, we call this permutations with repetitions. Whenever you have repeated letters, you just divide by the number of repeated letters factorial. So that's why every book, every math book there ever is, always has Mississippi in it. A lot of I's and P's and S's. I don't like to use Mississippi, I like to use alfalfa. There's 7 letters. How many 7-letter words can you make using the letters of the word alfalfa? Well, if they were all different, the answer would be 7 factorial. But how many A's are there? 3. L's and then F's. Get it? Just divide by the number. And in our old pre-calculus book, you know what word they had? They had anti-disestablishmentarianism. And that's dumb because you gotta count. Who's gonna count? Who's gonna even count how many A's and stuff there are in there? It's crazy. Okay, now, do you really think I'm gonna give you like Mississippi or Hawaii? No, that's too easy. So, what time is it? 8 minutes. Okay, suppose you have a map of a city block, okay? 1, 2, 3, 4, 5, okay, and then a little bit different than tonight's one. So this is a 5x4 city block. Tonight's one is 6x4. So if you can only move east or south, no backtracking, how many ways are there to get from A to B? How many ways, how many paths can I go from A to B? So here's one. What are you going to do? Use the method of exhaustion. Count them all up. 1, 2, 3, and keep counting. That's ludicrous. I'm going to tell you already since we're running out of time. So no matter what path you take, how many times east do you have to go? No matter what. To get from A to B, how many times east do you have to go? 5 times east no matter what, right? And no matter what, how many times south do you have to go? So this problem just boils down to how many words can you make? Every time you make a new word, that's a different path, right? So this is alfalfa. This is Mississippi right here, this problem. So how many 9-letter words can you make with 5 E's and 4 S's? Well, if they were all different, the answer would be 9 factorial, but you got 5 E's, so 9 factorial, 4 S's, 9 factorial. Boom, finish. Okay, so that's an application. Now, okay, we'll do this tomorrow. I gotta make sure I finish it. But you did this problem in elementary school, except you didn't do it this. Okay, the balls in the boxes problem. So suppose you have, now tonight's homework, you got 8 identical balls put into 3 boxes. Let's do 6. You have 6 identical balls. Let's do 7. I have 7 identical balls. How many ways can I put them into 3 boxes? Let's go. Now these are identical balls now. These are not, like, you can't tell the balls apart. How many ways can you put them into 3 boxes like this? Oh, you could go like this. I can put all 7 in A, or I could put 6 in A, 1 in B, none in. Or I could put 5 in here, 1 in there, no. 2 in there, none in there. 5 in there, 1 in 1, 5, 0 in 2. But there's a better way. I can tell you very quickly because, yeah, we're just going to use alfalfa again. Okay, so you have 6 balls. Now, if you're going to put them into 3 boxes, basically then you just need 2 dividers like that. Right? Because you put the 2, think of it as sticks then. You put these 2 sticks in, that means 2 goes in the first box, 3 goes into the second box. 2. What if you put the sticks like this? What does that mean? Put 6 in the first box, 1 in the second, and none in the third. What if you put the sticks like this? None in here, all 7 in the second box, and none in the third box. So the problem just boils down to how many ways can I put these 2 sticks among these 7 O's? Or, again, alfalfa. You got 7 O's and 2 I's. Because every time you make a new word, that tells you how to put them into the boxes. So how many 9-letter words can you make with 7 O's and 2 I's? Quick. 9 factorial, if they were all different, but then you got 7 O's, 7 factorial. Okay, 2 I's, 2 factorial. Okay, so that concept of Mississippi is so easy, but then you can use it to solve. And then last thing for today. If you have 5 people, or doesn't have 6 people then, Alfredo, Bernardo, Carlos, Diego, Eduardo, Fuego, how many ways can I arrange them in a row on a bench or in 6? But now, well, how many ways can I arrange them around a circular table? Why is because 1, 2, 3, 4. Like over here. If you put them all in a row like this, what if everybody stands up and moves one down and then come to the front? Isn't that a new arrangement? Okay, but over here, if they're sitting around a circular table like this, what if everybody stands up and rotates one to the right? Isn't that the same order? On the table clockwise, you encounter them in the same order. The answer is the same. So when you have circular tables, what you do is you fix one person, like you say, Carlos, you must sit here. This is to take care of the rotations. Once Carlos sits down, how many choices do you have? So what's the answer then? 5 factorial. So if you want to memorize a formula, this is it. How many ways can you arrange n people around a circle? If you're arranging them all in a row, the answer is n factorial. Difference? That's because in a circular table, there's n rotations. So you got to divide that by n, and then you get that. What time is it? We got 1 minute left. Okay, so on the test, you're probably going to get the prom problem. Okay, let's do this quick. You guys ever heard of these things called proms? See, when you go to the hotel, you have 10 people, but usually there's 5 couples, right? how many ways can you arrange 5 couples around a circular table if each couple must sit next to each other, because that's how it starts. So if people have to sit together, instead of making separate seats for them, what we do is we make, because they have to sit together. You understand what I'm talking about? So instead of making 2 separate seats, you put a love bench. So how many ways can you arrange 5 benches around a circular table? 4 factorial. Remember, it's n minus 1 factorial. However, on this 5 bench got 2 people, how many ways can they be arranged? 2 factorial. Down. 2 factorial. 2 factorial. This is called. That's how many ways you can arrange 5 couples around a circular table. If that problem is going to be a test, but I'll probably make 6 couples. Or maybe I'll make triplets. Or triplets. Same, it's the same concept.
That's still prom though?
They can go to a prom if they want to. I don't know what the circumstances, but they have to sit together. So when people have to sit together, you make a love bench. That's what you do. I'm sure you're going to have questions on that tomorrow, so we'll clear it up.
Last question on homework is a probability question.
I don't think I asked the probability question.